Hello students, I hope you are good, well and fine, and today we will be continuing our discussion on the topic of NCERT Exercise 1.1 Class 12 Chapter 1 Relations and Functions. Okay, let's solve with me. Okay, so question 9 says that show that each of the relation are in the set. So this is our set given to us. So this means if you see carefully that x belongs to the set of all integers such that x must be greater than equals to 0 but less than equals to 12. This means if you try to list all the elements, what you will get 1 2 3 till 12. Yes. Okay, now the first part of this question 9 says that this is our equivalence relation and find the set of all related to 1 in each case. Okay, so what we need to find? First of all, we need to show that part 1 and part 2 our equivalence relations, and then we need to find out all the elements which are related to the element 1. Okay, I hope this is very clear to you. So let's try to find out. Now if you try to find out for the first part, let's write all the elements if we can. Okay, so AB such that A minus B is a multiple of 4. Okay, and AB must belongs to set A. So let's write all the elements. Okay, so A minus B must be multiple of 4. This means 0, 4, 0, 0, 0, 0, 4. Okay, so because when you A minus B take modulus of A minus B, you will get the answer multiple of 4. Now what? 0, 8, 0, 12. That's it. Okay. Now for if you write more 1, 1, and what you will get 1, 5. Yes, 1, 5, and not this sign, comma, 1, 5 and 1, 7, no, 1, 9, 1, 13, but 13 is not in our A set element. Okay. Okay. That's it for 1. Now 2, 2, 2, say 6. Okay, 2, 6, 2, 10. Okay. 2, 10, and are there any number related to 2? No, because if you try to see that 2, 14 will be the next number such that 2 minus 14 will be your what? Modulus of 2 minus 14 will be 12, but 14, this number must also belongs to the set A. Here it doesn't belongs to the set A, so we cannot write 2, 14. So let's now jump to 3, 3. So 3, 3, this means 3 minus 3 will be 0, and 0 is the multiple of 4. So this means 3, 3, 3, say what? 3, 7. Okay. So 3, 7. Now 3, 11. Okay. And no further elements. Now 4, 4, 4, 8, 4, 12, and what? 4, 12. Now what? Now for 5, as there are many elements, don't write all the elements. As you can see that we are taking too much time to write all the elements. Okay. Yes. Yes. Just try to solve by this definition. Okay. Now let's solve it by just definition as we are given in this form. So let's see, is it reflexive? Is it reflexive? So for reflexive, to show A comma A belongs to the relation R for every A belongs to A. So we know what we know. Proof. We know what we know is this, that A minus A is 0, and which is multiple of 4. How it is multiple of 4? When you multiply 4 with 0, you will get 0. So it is a multiple of 4. So A minus A is multiple of 4. This means mod of A minus A is also equals to 0. So this means it is the multiple of 4. Multiple of 4. So this means it is our reflexive. So this relation is reflexive. Okay. So this is reflexive. Now let's check for symmetric. We know for symmetric, what we need to show? First of all, given, we are given with the piece of information that AB belongs to the relation R, and to show in case of a symmetric relation, we always need to show that B comma A belongs to the relation R. So as we are given with this, so this means A minus B, the modulus of A minus B is equals to the multiple of 4. Multiple of 4, and we know from this you can write that minus of B minus A, or you can say just B minus A is equals to minus of A minus B, which further can be equals to minus 1 times A minus B, which is equals to mod of A minus V, which is equals to, we already know it is multiple of 4, multiple, okay, of 4. So this means mod of B minus A is also multiple of 4. So this means it is also symmetric. We proved this also. So symmetric. Okay, now let's do the transitive. In transitive, if you recall, what we know is given thing. So what we are given with? We are given with AB belongs to the relation R, as well as B comma C belongs to the relation R. In transitive, what we always need to show? We always need to show that A comma C belongs to the relation R. Let's try to show it. So from this I can say A minus B length is equals to the multiple of 4, and B minus C is also multiple of 4. And here to show that it belongs to R is same as to show that A minus C modulus A minus C modulus is equals to multiple of 4. Yes. Okay. Now how you are going to show that? It is quite easy. What we know? We know A minus C modulus is multiple of 4. This means from this A minus C, if you remove the modulus, you will also get A minus C as multiple of 4. So you show this or this is same thing. Okay, and from this I can also say that A minus B also multiple of 4. Okay, and from this I can easily say that B minus C also multiple of 4. Yes, A minus C is also multiple of 4. And if you what? Because A minus B is also multiple of 4, A minus B is also multiple of 4. This means A minus B can be equals to 4 times some integer. This means K is some integer. Okay, and from this what I can say is B minus C is equals to 4K2, where K2 is some integer. Okay, some integer. If you add both of this, what you will get? Adding both equations, what I will get is A minus C, which equals to 4K2 k plus k2, and I know that k is an integer, k2 is also an integer. If you add two integer, what you will get? An integer, an integer, an integer. So this implies that a minus c is equals to multiple of 4. So as you can see, 4 times some integer is multiple of 4. So this means if you try to apply modulus, you will get the multiple of 4, multiple of 4. Okay, so from this you showed that mod of a minus c is multiple of 4. From this you can easily write that a comma c belongs to the relation R. Yes, yes. So this means it is also the transitive. So we showed that it is reflexive, symmetric, transitive, and so this means this is an equivalence relation. Okay. Now what? Now try to find that what elements are related to 1. As we already wrote all the elements related to 1 here. So as you can see, 1 is related to 1 itself, 1 is related to 5, 1 is related to 9. Okay, as it is symmetric, you also get that 5 comma 1 will be pair in this relation, 9 comma 1 will also appear in this relation. So as you can see, these are the only possible pairs in which the 1 is there. Okay, as you can see, the 1, 5 and 9 are the only elements from the set A which is related to the element 1. Okay, I hope this is clear to you. So 1, 5, 9 is our set. Okay, now what? Now in this case, the second part, if you try to find out the second part, first of all let's list out if we can. I think the list is small in this case, that's why I'm going to list all the elements. So pair AB such that A is equals to B. Okay, so the second part, okay, second part, R is equals to 0 comma 0, 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5 till 12 comma 12. Yes, okay, as you can easily see, what it is reflexive directly because A comma A belongs to the relation R for every A belongs to A. Take any A, if you can take, we know 0 comma 0 belongs to 1 comma 1, 2 comma 2, 3 comma 3, 12 comma 12, any number, 4 comma 4, 100, 10 comma 10. Okay, so all these pairs belongs to the R by just definition. It is already given by definition. We can say that it is reflexive. Okay, by definition it is reflexive. Now for symmetric, we know whenever A comma B belongs to the relation R, whenever A comma B belongs to the relation R, then B comma A also belongs to the relation R. Then we can say it is reflexive. So if you can see 0 comma 0 belongs to R. So if this is my A, this is my B, then B comma A will be also 0 comma 0. Yes. So if you see 0 comma 0 belongs to R, then 0 comma 0 also belongs to R. Okay. A comma B belongs to R. Then if you replace them, B comma A is also 1 comma 1. So it also belongs to R. So whenever this happens, this is going to happen, as you can see easily. So this means that it is symmetric also. Okay, so there is no contradiction in the definition of symmetric relation. As well as if you try to see for transitive, we know for transitive A comma B belongs to R, B comma C belongs to R. From this A comma C also belongs to R. Yes, A comma C belongs to R. And if you recall, not transitive, we know there exists at least one pair, one, at least two, not two, there exists at least pairs, at least what I can say is there exist, not say, so there exist such pairs, okay, such pairs A comma B belongs to R, B comma C belongs to R, but so there exist at least a pair, at least a pair A comma C such that A comma B belongs to R, B comma C belongs to R, but A comma C does not belongs to R. Yes, that's how we every time showed that my relation is not transitive. Yes, how we showed, we took two A comma B belongs to R and B comma C belongs to R, and we showed that A comma C does not belongs to R. If this happens, we say that it is not transitive. So we can say that there exists at least a pair A comma C such that AB belongs to R, BC belongs to R, but A comma C does not belongs to R. So if you can see that this definition is not going to follow here, as you can see that A comma C and B comma C belongs to R, but there does not exist any such pair A comma C which does not belongs to R. So by this definition it is not transitive, so I can say it is transitive, or you can say that it does not contradict any part of this definition, so I can easily say that it is transitive. Okay, whenever you see here, if you try to apply this definition, what you will get that AB belongs to R. Yes, AB belongs to R, but you cannot find this condition to be applying here. Why? Because there are no elements starting with this element. Okay, so as you can see that 1 comma 1 is there, yes, but there is no other element which is starts from 1. Okay, so from this, whenever this case happens, this satisfy and this is not there. Okay, we are not saying that it doesn't satisfy, but we are saying that it is not just there. Okay, so in those cases we also says that my relation is transitive, so this means it is also transitive. Okay, you can understood by this or by this. Okay, so from this what I can say that it is an equivalence relation, and if this is an equivalence relation, now let's find out the element which is related to 1. As you can see, the only element related to 1 is 1 itself, so the set is just 1. Okay, so this is 1. Okay, now what? Now we showed that 1 comma 5 for this set and 1 for this set. Okay, I hope this is very clear to you. Let's see what is our answer. So indeed, for first part 1 comma 5 comma 9, and for second part just 1. Okay, let's move to the next question. So next question, the question 10th. Question 10th, what it says? It says, give an example of relation which is symmetric but neither reflexive nor transitive. So what example can you think of? So what example can you think of? I'm doing half of the questions out of these 5. Rest of will be homework for you. Okay, so for first, the relation will be symmetric. Okay, if A is my what? 1 comma 2. Okay, then my relation I define is like this: 1 comma 2, 2 2 comma 1. So is this symmetric? Yes. Whenever a comma b belongs to there in the relation, the b comma a must also belongs to the relation. As you can see here, it is symmetric, but it is not reflexive. Why it is not reflexive? Because 1 comma 1 is not present here. And why it is not transitive? Because 1 comma 2 belongs to the relation, 2 comma 1 also belongs to the relation, but 1 comma 1 does not belongs to the relation, as a comma b belongs to R, b comma c belongs to R, but a comma c does not belongs to R. Okay, so I hope this is clear to you. So a is equals to 1 comma 2 and R, what is my R, is 1 comma 2 and 2 comma 1. I hope this is very clear to you. The example here. Now what? Now just see for a second. Try to think of an example of a relation such that it is transitive but neither reflexive nor symmetric. Quite easy. Does it quite easy? Yes. What if you try to write a as 1 comma 2 and R as what? 1 comma 2. Okay, 1 comma 2, and let's say a will be of 1 comma 3. So 1 comma 2, 2 comma 1, and what? 1 comma 2 and 2 comma 1 and 1 comma 1, also the 2 comma 1, the 2 comma 1. So we need the transitive relation here, but not the reflexive and the symmetric. So how we cannot get the symmetric? So it is quite easy. Just remove the wherever it is going to be symmetric. Okay, so say 2 comma 3 here and 1 comma 3. Yes. If you now see, is it reflexive? No. Why? Because 1 comma 1 does not belongs to R. So it is not reflexive. Is it symmetric? No, because 1 comma 2 belongs to R, but 2 comma 1 doesn't belongs to R. Yes. Is it a transitive? Yes, indeed it is transitive. Why I am saying it is transitive? Because whenever a comma b and b comma c belongs to R, then a comma c must also belongs to R. As you can see, 1 comma 2 belongs to R and 2 comma 3 belongs to R, and then we have that 1 comma 3 belongs to R. So from this I can say whenever a comma b and b comma c belongs to R, the a comma c also belongs to R. So this is an example for transitive but neither reflexive nor symmetric. Okay, I hope this is also clear to you. Okay, we are just thinking by definition, and we are creating all the examples we need here. So for here, reflexive, symmetric but not a transitive. So how can you make? So let's find out. So it must be reflexive, it must be symmetric. So it is quite easy. If you see that, if you take a as 1 2 and R as, so it must be first of all reflexive. Okay, so for reflexive the pairs must be there. Okay, now for symmetric, if you see what if you see, so 1 comma 2 if belongs to there, then what, say 3 here, so 3 comma 3, so now 1 comma 2 belongs to there, then 2 comma 1 must also belongs to there. So it is a nice example for reflexive, because 1 comma 1, 2 comma 2, 3 comma 3 are there, and for symmetric a comma b belongs to there, a comma b belongs to there, then b comma a also belongs to there. So this is true. But if you see for let's say for 1 comma say 2 3 and 3 2. Okay, so 2 3, now if you see the symmetric is true. Why? Because 2 3 and 3 2 belongs to there. Okay, but transitivity is not true. Why transitivity is not true? Because if you see that 1 2 belongs to R and 2 3 belongs to R, but 1 comma 3 does not belongs to R, as you can see. So from this I can say that if I take 1 2 3 as my set and my relation is like this, then my relation is reflexive, symmetric, but not transitive. Okay, I hope you understood how I am creating these. I am just satisfying the conditions according to the question I am faced with. Okay, so if reflexive, then first of all I listed all elements with it satisfied the reflexive property. Then I created more pairs to satisfy symmetric, but I created further pairs to satisfy not transitivity. As you can see, 1 comma 2 and 2 comma 3. From this, if you see that 1 comma 3 does not belongs to the R, so this means non-transitive. Okay, so I leave these two fourth and the fifth part to you, as you can create without any facing any difficulty. So thank you. That's it for today. We will meet next time. Thank you.